my name is Kyle Cook. I'm the project lead for the UNCC Tube team, and this is our finished Senior Design 2 Expo presentation. My teammates are Ali Iftikhar, Bjorn Bovum, Matthew DiVittorio, and Karen Valiant. This is a university project, which means we don't have an industry supporter, but our faculty mentor is Dr. Jerry Dahlberg. If you would like to see a full-size version of the poster on the previous slide, then you can simply stop the video here and scan the QR code. It will take you to a website with a full-size image and a download link so you can take a closer look at anything you may be curious about. Without further ado, let's jump right into the design requirements and purpose. Essentially what we have created is an oven, with the sole intent of creating carbon fiber tubes and airfoils. Primarily tubes though, as these tubes will be used by the UNCC rocketry team for their flight experiments. As such, the tubes must be of sufficient geometric conformity, desirable material properties, and quality surface finish for flight. The oven must operate safely and be easy to use for any user, and the end goal of the project is to save UNCC money by way of providing them a means to manufacture their own carbon fiber parts. The oven is a repurposed and modified wall locker which has been bolstered with an exterior 80-20 frame to mitigate the high bearing stresses associated with the mandrel loading process. This will be discussed more later. The interior of the oven is fully insulated and wired with heating elements. It is expected to operate for a couple hours at a time in a heating environment in between 250 and 375 degrees Fahrenheit. The heating elements chosen are identical to the ones that you would find in a household oven. The wires that power them run behind the insulation and out the back of the oven through several drilled holes, and they connect inside of the control box. All three make up a total of 1500 watts of heating power for the whole oven. This translates to about 5118 BTUs per hour. The mandrel mounting system is such that it consists of three pieces: the mandrel hanger bottom plate, the mandrel hanger top plate, and a 1/4-20 threaded rod to connect to the two plates. The carbon fiber tubes will rest on the mandrels, and the mandrels will sit around the rod in between the two plates. As you can see in the picture on the right, the top plate has a slot milled out of the center of it. This U-shaped slot allows for easy mounting and dismounting of a mandrel. The control system consists of a particle photon mounted to an NCD4 relay board. We'll be using a thermistor as a temperature sensor, and the thermistor signals will be used to dictate when the relays open and close. These relays are connected to the heating elements, thereby effectively providing means to turn the oven on and off as needed to respond to changes in temperature. The code is easily accessed via the web, and since these are IoT devices, online functions are possible, such as sending the user an email when the cook is complete. To date, the oven is completed, with the wiring and testing code also complete. Our first carbon fiber prototypes are being developed now, and one of them is pictured in the right. Thank you for taking the time to watch, and have a nice day.